All right, welcome everyone. Really excited to share this vulnerability that my co-author Eric Johnson and I found earlier this year. We've been waiting almost a year to be able to share this information with you, and I'm really excited to do so in this webcast. This is something that we found as a result of working on our course, Sec 510 Cloud Security Controls and Mitigations. So a lot of the content that you'll be seeing today is covered in the course as well, and many other related topics are covered there as well. So we're going to first talk about the problem in general, and that's why we say that this is a webcast that you need to know something about, even if you've never worked with Microsoft Defender for Cloud before, because we need to understand how we can securely give our cloud data to third-party vendors, because the way that we do that is going to really impact our security. We're then going to go into the specifics about Microsoft Defender for Cloud and their CSPM offering. We'll talk about the vulnerability. And because the vulnerability has been fixed, I've created a sample application that has a very similar vulnerability that you can play around with after this webcast and hopefully be able to simulate a similar issue to what we saw in Microsoft Defender for Cloud. We'll talk about some other integration risks associated with cloud vendors. I've got a bonus case study that's related to this example, but not exactly the same. And then we'll wrap things up. So first, let's talk a little bit about what we want to do to ensure that we are securely integrating with the vendors that need our cloud data. And there's a lot of use cases for sharing our cloud data with a third-party vendor, both for functionality purposes and for security purposes. And in this webcast, we're going to be talking about a vendor, Microsoft Defender for Cloud, which is a security vendor. And we're going to talk about how their integration had some problems that we needed to remediate from a security perspective. So at a high level, we want to make sure that you trust your vendors as little as possible while maintaining the functionality of what that vendor is attempting to do. So firstly, and this one's relatively straightforward for those who have taken Sec 510 or have studied Cloud IAM in general, which is that you do not want to give these vendor services unnecessary identity and access management permissions. We want to give these vendors the exact amount of permissions that they need in order to interact with our cloud in the way that they need to interact with our cloud in order to get the job done. The second one you might be familiar with, but it's a little bit more advanced, is that you need to use workload identities, not long-lived credentials. Now, we could have an entire webcast on workload identity, and in fact, we do, and I'll be linking to that at the end of this webcast. But at a very high level, what workload identity allows you to do is instead of giving the vendor, let's say Microsoft Defender for Cloud, a long-lived username and password or an access key ID and secret access key, we're going to create a trust relationship where these two different identity providers can exchange credentials with one another. So we're going to say that Microsoft Defender for Cloud will be trusted and can access our AWS account. And whenever Microsoft Defender for Cloud presents a relevant credential, our AWS account is going to exchange it for temporary credentials that it can use to get into our AWS account and, for example, scan the environment. The third one, and the one that's most relevant to this webcast, is that we need to prevent the vendors of their customers from reusing your trust relationship. When we give Microsoft Defender for Cloud access to our data, from a technical perspective, there is nothing stopping Microsoft Defender for Cloud from taking our data and sharing it with our competitors or making it publicly accessible. They have no intention of doing so, or else they would not be a great vendor. And I'm not here saying that Microsoft Defender for Cloud is a bad tool. In fact, I think it has a lot of great use cases. But from a technical perspective, there's nothing stopping this vendor that we've granted these permissions from being able to use those permissions to share your data with third parties in a way that you would not like them to do so. There are things that we can do on our end to limit the possibility that this happens. This is not something that we can control 100% on our own. This requires conversations with our vendor, but there are some techniques like the ones that we'll be sharing in this webcast and in my demo that will minimize the likelihood that this happens, that we can implement 100% on our end. And finally, we need to clean up the required IAM resources after terminating the connection. When you stop using a cloud vendor, all you're saying to the cloud vendor is, I no longer want you to perform operations on my cloud account. That is not revoking their permission to access your data. Because if you've established that trust relationship and the vendor decides to use it, and later on you say, vendor, I don't want to use you anymore, that doesn't break the trust relationship. That's something that you need to adjust on your side in your cloud account. So these are the 4 things that I'd recommend thinking about whenever you're thinking about using a vendor that needs direct access to your cloud data. If the vendor wants your cloud data, they must support these requirements. Otherwise, maybe rethink that vendor or ask them to implement these controls. So let's talk about Microsoft Defender for Cloud specifically. So there are a variety of different cloud security posture management tools out there, or CSPMs. And you've heard of a lot of these tools before, a lot of these companies before. And the idea behind a CSPM is we're going to allow this service to scan our cloud environment and tell us when there are issues with our cloud configuration or other issues that imply that there might be a security problem. Most of these CSPMs support multiple cloud providers. They want your business, and as a result, they want to integrate with as many cloud providers as possible so that they can meet the customers where they are, whether or not they're an AWS, Azure, or a Google Cloud customer. There are also CSPMs that are native to the cloud environments, but those CSPMs are largely focused on their own cloud provider, except for Microsoft Defender for Cloud. Microsoft Defender for Cloud is the only, or at least the first of the cloud native providers that can monitor external cloud providers. Google says that they have one that's coming out. I don't know really what the status of that is. I heard that there was an alpha going on, but in terms of something that's generally available, Microsoft Defender for Cloud is, as of this time, the only cloud native CSPM that allows you to scan other cloud providers. And this, from a business perspective, makes a whole lot of sense. Azure is not in first place right now. They are in second place to Amazon Web Services. So they want to make the case that you can use Microsoft Defender for Cloud to better secure your AWS accounts. And then they can get their foot in the door and say, hey, if you're already using Azure to manage your AWS accounts, take a look at all these great services that we offer. So I think that this is a really smart business play, and I definitely understand why they'd want to have an offering like this. So we're going to be specifically focusing in this webcast about how we are going to allow Microsoft Defender for Cloud to scan our AWS account. And this requires a couple of different components. One of those components is a workload identity. Again, we're not going to give Microsoft Defender for Cloud permanent access to our environment using long-lived credentials. Instead, we are going to create a trust relationship where our AWS account is going to trust the identity provider associated with Microsoft Defender for Cloud. Once we have this trust relationship, we are going to allow Microsoft Defender for Cloud to assume an IAM role, which will give it the necessary permissions in order to scan our environment. And finally, separately from that, we are going to have Azure actually connect to our AWS account. And Microsoft Defender for Cloud combines all of these steps in the same setup wizard. They will give you a piece of infrastructure as code, either CloudFormation or Terraform, that you're going to download. You're going to deploy it to your AWS account. And then finally, you're going to click a button that's going to say, hey, Azure, I want to scan this specific account. And if you did the first 2 things, if you created the workload identity and created the IAM role using that infrastructure as code template, you will now be able to successfully make this connection. So here's the diagram of how this is supposed to work. Now, I want to make a quick caveat about this because this particular vulnerability was before Microsoft Defender for Cloud provided a Terraform template directly through their wizard. So if you go to the Microsoft Defender for Cloud webpage right now and you want to set this up, you'll be presented with a template, either CloudFormation or Terraform, which you, in this case, Alice, is able to deploy in order to create the resources required in order to make this integration happen. So they'd create the workload identity and the IAM role. For this vulnerability, we used a piece of code that was published to the official Microsoft Defender for Cloud GitHub repository, because at the time, they only supported CloudFormation. And we wanted to use Terraform because we use Terraform throughout our course. We wanted to set up a lab that involves Microsoft Defender for Cloud, and we wanted to copy and paste the code they provided in order to do this without having to set up CloudFormation. So that's exactly what we did. So we deployed this set of infrastructure, which created the resources that would allow Microsoft Defender for Cloud to trust, or sorry, for our AWS account to trust Microsoft Defender for Cloud so that Microsoft Defender for Cloud can scan our AWS account. Now, the final process on the consumer side is to actually click the button to connect Microsoft Defender for Cloud to our AWS account. So Microsoft Defender for Cloud is now going to create a database record. And the database record is going to say that Alice's Azure tenant, their Entra ID tenant, is associated with Alice's AWS account. So whenever I go to Microsoft Defender for Cloud, it's going to show me the results from Alice's AWS account. And then periodically, Microsoft Defender for Cloud is going to use its trust relationship to assume an IAM role, get temporary credentials, and then use those temporary credentials to scan for Alice's resources and any vulnerabilities that might be in those resources, that might be enabled as a result of a bad configuration. So that's how this is supposed to work. So what went wrong that resulted in Eric Johnson and I getting a bug bounty and resulted in me getting this awesome crew neck sweater that they sent me as a result of getting on their leaderboard? Well, it is related to what's called a confused deputy problem. And this particular slide is based on AWS's documentation because this is not a specific problem for Microsoft Defender for Cloud. Far from it. This is a very widespread problem. And their definition of the confused deputy problem is that it occurs when an entity that doesn't have permission to perform an action can coerce a more privileged entity to perform the action. And in this case, Microsoft Defender for Cloud is the deputy. And that's why I gave their logo a deputy's hat. We are granting Microsoft Defender for Cloud the permission to access our sensitive data. That's something that not everybody in the world can do. We can do it, and we have deputized Microsoft Defender for Cloud to be able to do it because we have created that trust relationship and that IAM role. Here's a scenario that AWS describes between AWS accounts, because you may have a vendor in one AWS account, and you may want that vendor to be able to access your data in another AWS account. So in this case, we're purely talking about intra-cloud authorization, not inter-cloud authorization. So let's say we have this vendor owned by Example Corp. Example Corp is going to scan this AWS account that, let's say, Alice owns. So Alice is going to give an IAM role to Example Corp. Example Corp will now be able to use that IAM role and the trust relationship that has already been set up earlier to assume a role and access resources in Alice's account. However, there may be another customer of Example Corp. Let's say that person is Eve. Well, Eve could theoretically also provide an ARN, the same ARN shown here, and say, hey, Example Corp, you have the permission to access the AWS account associated with Alice. I want you to use your permissions to access Alice's data and give me Alice's data. So Eve cannot access Alice's data directly, but Eve is able to trick this deputy that does have access to Alice's data to give that data to Eve. There are several things that can be done to mitigate this issue, and several of them can be done on the application side that Example Corp is providing. However, one of the mechanisms that you should implement on your AWS account is you need to be checking for a customer-specific value. So whenever some vendor wants to access your account, whenever they want to assume a role, they should be supplying some kind of external identifier specific to your identity, specific to Alice. So Example Corp should be saying, I am scanning this account on behalf of Alice. And the trust relationship should check to make sure that the scan is done on behalf of Alice. So if Eve tries to do the same thing, the vendor would say, hey, I'm doing this scan on behalf of Eve. And Alice's account would say, whoa, 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 whoa. I don't want to give Eve access to my data. I'm going to not trust this particular request. Now in AWS, we do this with what's called an external ID. That is the native way of limiting who can assume a role based on this kind of customer identity. But that attribute does not exist for external identities, identities that do not use assume role to get into your account, but instead use assume role with web identity, an external third-party identity provider. So for web identities, we can use the audience or subject claim in the JSON web token, or in the case that we're going to be exploring here, we can use the role session name. So we can make it so an Example Corp, for example, let's say this is Microsoft Defender for Cloud, which is not in AWS, wants to access our account, they would name the session after Alice. So we can then check the session name and make sure it matches what we're expecting. And then, of course, it's on the customer's responsibility to actually verify this value. So the vendor should provide the value and the customer should validate the value. And by the way, this value is not a secret by any means. It is simply indicating that this request was intended for Alice, so that Alice can see, hey, if this request was intended for someone else, I'm going to block it. In the case of the Microsoft Defender for Cloud Terraform template that we used, and this is specifically the Terraform template that was on the GitHub repository, that did not have a customer-specific identifier in the policy. So here's the scenario of what could go wrong that could result in sensitive data disclosure. Let's say Alice says, you know what? I don't want to use Microsoft Defender for Cloud anymore. I've done this evaluation. I want to use Wiz or Prowler or some other tool. So I'm going to tell you, Defender for Cloud, to stop scanning me. Well, Alice, when she says, I don't want you to scan me anymore, does not revoke the permissions that Microsoft Defender for Cloud has to scan their account, because they still have that workload identity pool and they still have that IAM rule. If Alice does not clean that up as we recommended in the final step in our vendor recommendations, then that means that Microsoft Defender for Cloud, technically speaking, still has access to Alice's account. But they're no longer going to scan Alice's account because they cleared that connection out of their database record. But here's where the trick happens. Let's say Eve says, hey, you know what? I want you to scan, quote unquote, my account. And Eve provides Microsoft Defender for Cloud with Alice's account. Well, Defender for Cloud is not going to have any context of who owns an AWS account. That's a completely external concept. So Defender is going to say, from as far as they're concerned, Eve's Entra ID tenant is now connected to Alice's AWS account. So now Microsoft Defender for Cloud will continue to scan Alice's AWS account, and send the results back to Eve. And the reason why this was possible is, number one, that Microsoft Defender for Cloud allowed you to delete that record from the database and then recreate it from a completely different tenant, but also because the IAM role in Alice's account is not validating that this request was made on her behalf. Here is the assume role policy that existed in Terraform for our particular setup that we mentioned before. So we have here the trust relationship where we're saying we are going to allow Microsoft Defender for Cloud to assume a role, and we're only going to trust their specific Defender audience. So this is a hard-coded audience field that is going to be in every single Microsoft Defender for Cloud scan. However, there is nothing in this template saying to check that this request was done on behalf of Alice's organization. So what Microsoft Defender for Cloud added to their Terraform template that was published to their user interface was this role session name check. So whenever Alice's tenant is used to scan Alice's AWS account, the role session name will be called Microsoft Defender for Clouds _ and then the identifier for Alice's tenant. So now we can say that we are only going to trust scans that are initiated by Alice's tenant. We are not going to allow for scans that are originating from Eve's tenant. And so long as the vendor supplies this information, and that information cannot be modified in some other kind of vulnerability, we can say fairly confidently that this request came from Alice's tenant and therefore it should be trusted. Whereas if the request originated from Eve's tenant, we would no longer allow the tool to assume the role. Now, one thing that's great that Microsoft Defender for Cloud did is they fixed this issue retroactively. So if you do not have this condition in your configuration, it will actually refuse to scan you. It'll use the IAM permissions that it has to look at the assume role policy that it used in order to assume the role. And if this clause is missing, it will reject the connection. So I cannot demonstrate this vulnerability that was fixed earlier this year around March because it was fixed in Azure. So instead, I'm going to demonstrate this with a custom application that we created in order to demonstrate this kind of issue, which we call the Confused Deputy Insecurity Management Platform. So this is a play on words of a cloud security posture management tool. We have this new type of tool that's going to scan our environment, and it's a brand new acronym, CDIM. So let's see how long it takes for Gartner to make a category for this kind of tool. So in this scenario, I am going to scan my account logging into the CDIM platform as Alice. So this is the equivalent of logging into your Microsoft Entra ID. I'm going to type in my password, and it's going to present me with a Terraform template that I can use to set up my AWS account to trust the CDIM. And that's what I have here that I've already deployed to my environment using the SANS Cloud Security Flight Simulator for my AWS account that I use for my labs. So we're creating this provider. We're going to trust the CDIM, and we are going to allow it to assume a role with a web identity as long as the subject is something that we are expecting. So that's already been set up. So now I'm going to take my AWS account ID over here, and I am going to say, I want you to scan my environment for vulnerabilities. So let's see if this works. So the CDIM is not the best security tool. It is a free tool, so therefore it's probably not the best in the entire world. So the CDIM is not going to actually tell you if your buckets are secure. They're simply going to list all of the buckets that are in your account and say, hey, maybe they're secure. I don't know, you figure it out. So we simply have this as a mechanism of proving that the CDIM has IAM access to our AWS account. The problem is that if nothing else changes, I can log in as a different user named Eve, and I can say, I'm going to log in with her much longer password, which I've memorized. And I'm going to say, I'm Eve. I know that the CDIM is able to scan Alice's account. I want you to scan Alice's account and give me the results. Well, when we do this, it still succeeds. Eve is able to scan Alice's account as well. The reason why this is allowed is our trust policy here does not have anything saying that this request was made on Alice's behalf or on Eve's behalf. So we can edit this trust policy accordingly. And the reason we're able to accomplish this is if we look at the actual code, and you'd have to consult the vendor about this because you don't have access to your code. Every time that they assume a role with web identity, they're going to name the session after the currently logged in user. So if this request is coming from Alice, it's going to be CDIM underscore Alice. And if it comes from Eve, it's going to be CDIM underscore Eve. So all we have to do is we have to modify this trust policy to have another clause that says we are only going to trust requests that come from Alice's user, that's only initiated by Alice in the CDIM platform. So let's update this policy. It's not going to take effect immediately. So let's go ahead and click scan again and see what happens. Oh, wow, that actually happened really quickly. It says access denied, not authorized to perform STS assume role with web identity. Why? Because we are logged in as Eve, and that means the application is going to populate a session name of CDIM underscore Eve, which is not going to match the policy that we have here specifically for Alice. Now, if I change, I'm going to do this one more time just for demonstration. Still denied. If now I'm scanning from Alice's account, it's going to still work because the condition is going to work in that case. And this tool can be found at cdim.cloudsecurityace.com. We have some more details on this that I'll share at the end in case you want to play around with this tool. So let me switch back to my PowerPoint presentation because we've still got a whole lot more to cover before we wrap up for the day. So that's a risk associated with items 3 and 4 in our general vendor integration recommendations. But we still need to consider about the amount of permissions that we are granting our vendor, because we believe that Microsoft Defender for Cloud is not going to use the permissions we grant them inappropriately. And in fact, that's the case. I have no indication of saying that Microsoft Defender for Cloud is going to purposefully abuse our trust relationship. But they can get hacked, they can be compromised, and we want to make sure that when Microsoft Defender for Cloud is compromised, if that ever happens, that people cannot use the permissions that we've granted them in order to do more nefarious things than we would otherwise need to grant. So we want to minimize the amount of permissions that Microsoft Defender for Cloud has to access our AWS account. And this is unfortunate because the default configuration that they still provide in the Microsoft Defender for Cloud user interface will grant Microsoft Defender for Cloud read-only access, which doesn't just allow access to configuration details, but could also result in actual data exposure. Now, Eric complained about this before the main breach, or the main vulnerability, I should say, that we found. And he complained about this, and they said, okay, that's a medium issue. We are going to add a little box that you can check, a little radio button that you can select. And if you decide to use a more restrictive IAM policy, you can do so. And we'll modify our template to, instead of having read-only access, to only have still 200 permissions plus, but we will also deny things that we know should never be accessed by Microsoft Defender for Cloud, such as billing details, which it has no business looking at. This is not on by default. You have to actively select that radio button to say, I want to use the least permission policy. And the reason why this is not the default is that Microsoft Defender for Cloud is constantly evolving. And as a result, they would need to change this policy every time that they want to scan a new service. So if AWS comes up with a brand new service, they would need the customer to modify the permissions in order for it to be able to scan that service. So here's the full timeline of the issues that we reported. As mentioned, Eric reported the excess permissions. They called that a medium issue, did not pay out a bug bounty for that. But then we used that to inform our Sec 510 labs. We created a lab surrounding Microsoft Defender for Cloud, and this leveraged that Terraform template that was published on GitHub. At that time, there was no role session ID check happening there. Then in January of 2024, I was creating a new lab on this subject regarding Microsoft Defender for Cloud. And Ken Hartman, another one of our amazing instructors here at SANS, gave me a recommendation about how can we abuse this trust relationship. And I looked into it, and I couldn't find any direct way that I could assume the role that Microsoft Defender for Cloud had access to. But I did discover that I was able to get Microsoft Defender for Cloud to scan other people's accounts using my account, my tenant, under these specific situations, the specific parameters that I mentioned earlier, such as if they use the GitHub template or if they disconnected from the tool. So they updated this in GitHub. They called this a critical vulnerability, did that retroactive fix where they make sure that they will not connect to tenants that do not have that condition. And they actually ended up removing it from GitHub altogether, as there was no real reason to deliver this template outside of the official wizard. So before we wrap up, I just wanted to give you an additional case study that is not related directly to Microsoft Defender for Cloud, but has a similar kind of issue. Because remember, one of the things you should take away from this lecture is that this is not a specific Microsoft Defender for Cloud kind of issue. You don't have to worry about this for Microsoft Defender for Cloud in this particular case. They fixed this issue, but you absolutely need to care about this in the context of other vendors. And a somewhat similar kind of case study happened relatively recently, last year, with GitHub. GitHub is the most popular place to store source code, and it also has a variety of other really cool features. One of those features is called GitHub Actions, where if you make a change to your code, it can automatically run some deployment that will modify your environment accordingly. So we can make it so that when you change your infrastructure's code, GitHub Actions can automatically apply those changes to your live cloud environment. However, for reasons that will be shown on the next slide, there was a bug in the way that people were implementing this, which resulted in any GitHub action to be able to assume a role into an AWS account that was configured in this fashion. We intended to have our AWS account trust a particular GitHub action, but in the process, we accidentally trusted every GitHub action to access our AWS account. This is something that was introduced in a very popular tutorial, and it resulted in everybody being able to push code to AWS's internal code repository code commit or pull the code as well. Now, thankfully, because of a variety of different security researchers, they were able to fix this issue in the UK government agency's GitHub repository, because they were one of the organizations that followed this tutorial, it seems. They were able to get the creator of the tutorial to fix the issue very, very quickly, impressively quickly. And they were able to get AWS to actually modify their setup wizard so that it's impossible to make this mistake in the future. And they even made a report with Terraform to tell them, hey, this issue happened as a result of this oddity in Terraform. Perhaps we should add a warning whenever this kind of mistake happens. because the underlying issue was with relationship to this function in Terraform called JSON encode. It's going to take your Terraform variable and convert it into actual JSON. But in JSON, you cannot have two keys with the same name in the same object. And this tutorial included two different string equals clauses. One that's going to check that this came from the repository or the organization that we trust, and that the audience has a particular value. So JSON encode saw both of these values and it didn't know what to do with it. So it simply squashed this first result as if this particular key didn't even exist in the first place and said, we're only going to check for this audience value. The way you're supposed to do this, and the way that this was fixed in the tutorial, is instead of having two different string equals clauses, they instead have two different values in the same string equals clauses that are going to check for both of these values. So the argument that they made to Terraform is, hey, you should probably have a warning whenever you're trying to JSON encode a value that is an invalid JSON object because it has two keys of the same name. Terraform has not addressed this yet, but I think it's something that they should absolutely do. But in the case of GitHub, this has been resolved for the other, using other mechanisms so that this cannot happen again. But I think that this general warning would be useful in other places as well, not just in the case of this confused deputy where we're tricking GitHub, which has permission to scan our AWS account, to scan from a different GitHub customer. So a kind of similar situation, a little bit different, but a similar situation that happened with GitHub to show you how widespread this kind of problem exists, how widespread the problem is. So I've got some additional resources to leave with you before we get into our Q&A. There's a lot of different materials that I put together on this particular subject. So this webcast was adapted, I should say, from the blog posts that I made on this subject. So if you go to sec510.com/mdc-vuln, that'll give you the full write-up on the subject, not only about what went wrong, but also why Microsoft Defender for Cloud did not have this issue with its scans of Google Cloud accounts. So if you wanted to scan a Google Cloud account using Microsoft Defender for Cloud, this particular issue did not exist. Why? Well, we detail that in that blog post. We also have another blog post about vendor integrations in general, which you can access and also get some details about how to use the CDIM if you'd like to use that for a demonstration purpose or to see it for yourself. We also have a webcast specifically on workload identity in case that terminology didn't make a whole lot of sense. You can refresh your memory by looking at this content or learn about it for the first time. And we also have some resources related to the course that we think will be valuable to you. Namely, we have a poster that shows a variety of other misconfigurations that can happen, as well as we have a cheat sheet that shows you some of the commands that you can use across multiple cloud providers to perform various security operations. And if you liked this webcast, please, please, please take the opportunity to go to sec510.com/demo, log in with your SANS account, and you'll get a free hour of content from this course. This is something you can do for any SANS course. It's awesome. You could do it for every SANS course if you'd like, and I wish more people took advantage of it. If you want to attend the full course, we'll be teaching it several times throughout the remainder of the year and many, many times in 2025, of course, as well. Ken, who is the person who helped me find this issue in the first place, is going to be teaching this in Orlando, or you can take it from your own home in the same time zone from the end of October to the beginning of November. My co-author, who also is the co-author of this bug bounty, Eric Johnson, will be teaching the course in San Francisco in the middle of November before Thanksgiving, so a week before that. And if you want to take the course at your own pace, you can take the course anytime, anywhere with me on demand. I'm very proud to have some really solid endorsements of this course. I really want to thank Josh for saying that this is his favorite SANS class that he's ever taken, and he's taken quite a few. I also appreciate Chris for highlighting how the lab environment is highly realistic and multi-cloud. The CDIM is only one small portion of our lab environment that we use for a single lab. We have so much more. And Sean, thank you for mentioning that if you cloud, you need this course, period. And with that, folks, we've got 20 minutes for any Q&A you might have. Mohammed says, what is the best vulnerability assessment tool for single and multi-cloud environments? I don't have a really strong opinion on this subject. Most of my focus is on the cloud native tools. And if I had to wager, I would say that while Microsoft Defender for Cloud is, probably a very solid tool, it's not their main core competency. Whereas, Wiz and these other companies, all they do is CSPM. So if I had to guess, I would say that the third-party vendors are probably a little bit more feature-rich, but I haven't played around with enough of them to say definitively which one I'd like to use versus others. That being said, Wiz was almost acquired by Google for like $1 bajillion, and their research team is fantastic. So you definitely have to take a look at them because they're clearly doing something right. I don't have any direct hands-on experience with their actual tool, but clearly they're doing something very well. Dustin says, if access to AWS from Defender was provisioned before this issue was fixed, is action required to mitigate this issue? And the answer is no. And this was something that I thought that Microsoft Defender for Cloud would need to have customers do. I was concerned about that. But what they did was very clever. So Microsoft Defender for Cloud, when you granted it permissions to access your account, you also gave them the ability to look at your IAM policies. So what they did, which was really clever, is they said, whenever you want to connect to a new Defender for Cloud account, we are going to see if we can assume that role. And before we actually create that database record, we are going to use the IAM permissions that we have to look at your template. And if your template is missing that value that we need to check for, we are going to refuse the connection. We are going to drop the connection. So this will functionally make it so that you cannot connect to any account that has the vulnerable template anymore going forward. And they've, as far as I can tell, identified the people who were affected and reached out to them as well. So this issue should not exist anymore. There should not be any additional action that you need to take in order to remediate this. However, I'll get back to what we said at the very beginning. If you used Microsoft Defender for Cloud and you are no longer using Microsoft Defender for Cloud, and the same thing is true for any other vendor, you should completely eliminate the trust relationship, because even though this is a mitigating control, technically speaking, Microsoft Defender for Cloud still has access to your data. And that's true for any vendor that you used to use. So I would explicitly delete this trust relationship, even though this particular issue has been mitigated retroactively. If you used a vendor and you have a trust relationship, get rid of it if you're no longer using that vendor. Joseph says, for short-term identity, it could be renewable and regenerated automatically, so it wouldn't affect the integration between the CSPM and the CSP. So if I follow you correctly, we're saying using temporary credentials. So that's actually what's happening by default with workload identity. We're creating this trust relationship between the CSPM and the CSP. So when the CSPM provides an identity token to the CSP is going to deliver it temporary IAM credentials to access the CSP. And those are going to be regenerated by default consistently. Now, if you're saying, how can we regenerate the trust relationship, that would require the user to redeploy these resources on a periodic basis, which I think is quite impractical, honestly. So I would say that that is probably not something that we'd want the customer to have to do. However, I would say that if you're no longer using this vendor, get rid of that trust relationship. And the vendor would be really nice if whenever you disconnected, they gave you a warning box saying, hey, we're no longer going to scan you, but you've technically still given us permission to access your data. If you want to revoke that permission, do this, or maybe even run this script, which is going to eliminate that trust relationship. Because Microsoft Defender for Cloud does not have permission to terminate the trust relationship. Because if it had that permission, it could terminate other people's trust relationships. Microsoft Defender for Cloud purely has read-only access, so you would need to use your write access in order to eliminate that trust relationship. Has this been patched in all cloud platforms that use Defender for Cloud or just Azure? So I want to make this very clear. This vulnerability is specifically regarding Microsoft Defender for Cloud scanning AWS accounts. This vulnerability does not exist for Azure scanning Azure for good reason. Azure does not need this trust relationship to trust Azure because it is Azure. So the only other kind of place where this vulnerability might exist is for other third-party integrations. That is not something that was the case for Google Cloud. And there are details in this resource that we have here on the vulnerability itself. If you go to this URL, it'll explain exactly why this vulnerability did not exist for Google Cloud. They have other integrations that I have not personally vetted, but I have to imagine that they have looked into this in more detail after this critical vulnerability because they don't want to have to pay me again. So I have to imagine that they have prevented this in these other third-party CSPs. But as far as we know, the only time that this issue has ever existed is between Microsoft Defender for Cloud and AWS, no other cloud providers. And it's definitely not possible for Google, explicitly not possible for Google using the same mechanism for reasons that we detail in that blog post. Joseph asks, so just to confirm my understanding, the temporary credentials are automatically generated and the trust relationship needs to be removed manually or revoked. Correct. As long as there's two things that we have to create. So we have to create the workload identity, which we haven't demonstrated the code that's related to this, but this is going to create a trust relationship between Microsoft Defender for Cloud and AWS. We're going to say that we are going to allow identities from the Microsoft Defender for Cloud Entra ID tenant to get into our AWS account. Then specifically, we have an IAM role that says specifically, we are going to allow this identity from this tenant to be able to get into our AWS account and get the permissions associated with this particular IAM role because we have granted it the assume role with web identity permission. So having the identity pool by itself doesn't do anything, at least not in this context. You also need to have an IAM role that allows identities established from that pool to get in. And this assume role with web identity is going to create temporary credentials. So anytime Microsoft Defender for Cloud needs to access AWS, it is going to run the assume role with web identity to generate temporary credentials to get into the AWS account. But Microsoft Defender for Cloud can do that as many times as they want, so long as this resource exists. So if you say, Microsoft Defender for Cloud, I don't want to use you anymore, stop scanning me, you still have something in your AWS environment saying that anybody coming from this Azure tenant, this Microsoft Entra ID tenant that meets this particular condition can generate temporary credentials for my AWS account. So the credentials are temporary, but they can be regenerated indefinitely until you delete this IAM role trust policy and or delete the identity pool. That will make it so that they can no longer regenerate those temporary credentials. That's destroying the trust relationship. I really want to thank Microsoft for their collaboration here. They took this issue seriously. They remediated it very quickly, as you can see on this timeline. We made the report in February. It was marked as critical and impossible to exploit a month later. It might have even been dealt with earlier before they told me that it was critical. They worked with me relentlessly on getting this presentation and the blog post out. The blog post itself came out in the middle of July because we went back and forth, and there were a lot of details that I missed. And they let me say whatever I wanted to say as long as we could both confirm that the statement was accurate. And I really appreciate that. I really appreciate them rewarding the work that Eric and I did. And I really think that that's great. And I hope that all cloud providers follow that same kind of model, because it really incentivizes the entire community to try to find these issues. And if there's anybody who wants to hunt for these kinds of bugs, I'll tell you right now, I was not looking for this issue. This issue came about because I was working with the tool properly, like on purpose, trying to use it legitimately, and something worked. And I was wondering, why does that work? And then I realized, oh, it shouldn't work. It's because of this template. Let's go report this issue. So I'm really thankful for them. And anybody else who wants to look for these kinds of issues, just keep that in mind, is that you don't necessarily need to go out and look for them. They might just come about when you're using some software that you're using extensively, maybe more so than the general population. All right, while we're waiting to see if there's any last questions, I wanted to mention, first and foremost, thank you for attending. Really appreciate it. I hope that you'll also take a look at the Sec 510 demo, which is again 100% free. You just go to sec510.com/demo, log into your SANS account, get another free hour of material. I hope maybe I'll see you all in a class sometime, and feel free to follow me or connect with me on LinkedIn. Hayes put the LinkedIn URL in the Zoom chat. You could also just look me up on LinkedIn as Brandon Evans Sands. There's quite a few Brandon Evanses, but only one that I could find in the security industry. So I guess I've cornered that market. All right, I see that there are no additional questions, so I think that we'll call this the presentation. So really appreciate your time. Make sure to follow me or connect with me on LinkedIn. Make sure to check out those additional resources if you think they'd be helpful to you. And until next time, folks, take care.